In the next two examples, now instead of looking at a graph or being given kind of shortcut pieces of information, we just want to start with a function, and we're going to use the second derivative test, meaning we're going to look at concavity to classify critical values as a maximum or minimum. That means we first need to start by finding the first derivative and any critical points for this function. F prime of x will be equal to 6x plus 4. Critical points occur whenever the first derivative function is equal to 0, meaning we'll set 6x plus 4 equal to 0, giving us 6x is equal to negative 4, or x is equal to negative 2/3. We only have a single critical value. It could be a maximum or a minimum or neither. We're going to start off by trying to use the second derivative function to classify this point. If we take the second derivative, meaning we're taking the derivative of 6x plus 4, we'll get 6 with no variable. So regardless of what we plug in this case x equals negative 2/3, we still get a value of 6 for the second derivative. That is positive, meaning our function is concave up. So the first derivative is equal to 0. The second derivative is something positive. That tells us that we have a local minimum. At x equals negative 2/3. In example 4, we want to do the same thing, but now we have a more complicated function. We still start off by finding the first derivative function, which will be negative 12x squared minus 2x. To find the critical points, we take that first derivative function, set it equal to 0, and solve. In this case, we can factor out 2x, which will leave us with negative 6x minus 1. And we get two equations to solve. The case where 2 times x is equal to 0, or negative 6x minus 1 is equal to 0. The first equation gives us x equals 0 as a solution, and the second equation will give us x equals negative 1/6 as a solution. Now we have two critical points. We'll have to test both of them in order to classify them. And we'll do that using the second derivative test again, meaning we'll find the second derivative of our function, which will be negative 24x minus 2. Then we'll find g double prime of 0, which will end up being negative 2, and g double prime of 0, g double prime of negative 1/6, which will be negative 24 times negative 1/6 minus 2, or positive 2. For g double prime of 0, we get a result that's less than 0, meaning our function is concave down. For g double prime of negative 1/6, we get a positive result, meaning our function is concave up. So if we have a critical value and the function is concave down, that means we have a local maximum at x equals 0. And if the second derivative, if we have a critical value and the second derivative evaluated at that point is positive, it's concave up, that tells us that we have a local minimum at x equals negative 1/6.